Hello all, welcome to the presentation. The topic of this presentation is comparative study and analysis of emotion recognition techniques as part of EEL 6825 pattern recognition. My name is Karan Acharikar and my UFID is 38689483. Now let's begin with the presentation. The first question which pops into your head is, what is emotion? An emotion is a particular feeling that characterizes a state of mind such as joy, anger, love, fear, lust, and so on. Emotion can be expressed in many ways that can be seen, such as facial expressions, gestures, speech, and by written text. Now, what is emotion recognition? Emotion recognition is nothing but the technique of discerning emotions of an individual from text, facial expression, or body movements. Emotion detection in text documents is essentially a content-based classification problem involving concepts from the domains of natural language processing as well as machine learning. Emotional state of a person can be detected by analyzing a text document written by him or her. The purpose is not to identify specific emotions but rather to find emotional state or mindset of a writer while writing the text. Emotion recognition has several advantages. It can help consumers make an informed decision when purchasing a product or service. It is always useful to have a list of opinions of existing users rather than going through numerous reviews to form a mental image of the pros and cons of the product. Opinion mining is an important aspect of businesses and organizations. It is crucial for a product manufacturer to know what the consumers think of their products and those of its competitors. Some other advantages of emotion recognition are in the field of information system. It can be used for summarizing reviews, classification of reviews, and numerous other applications which require real-time output. Emotion recognition has several challenges. The first one is keyword selection. Isolating a word from a sentence or document which is being examined is difficult. It becomes tricky to identify the sentiment because it is always possible to express sentiment in a delicate manner. The second challenge is domain specificity. Sentiment can be domain specific. Depending on the context they are used in, the meaning of words has a tendency to change. The third challenge is multiple opinions. It is possible for a sentence to have numerous opinions along with subjective and factual portion. It is rather difficult to seclude such clauses. Another challenge is negation handling. Attempting to perform negation in sentiment analysis can be a tricky task. For example, although I love this dish and I don't love this dish differ from each other only by a single token, they need to be assigned to a distinct and disparate class. The next challenge is sarcasm. The most difficult to identify tokens are sarcasm and irony. Sarcasm is all the time utilized as part of social media. They are rather difficult to identify because they are always expressed implicitly. Last challenge is comparative sentence. A comparative sentence makes use of similarities or differences of more than one object to express a relation between them. Example of fruit A is bigger than fruit B communicates completely opposite opinion from fruit B is bigger than fruit A. Emotion recognition has several approaches. They can be subdivided into machine learning approach and lexicon based approach. As part of our study, we will be looking at an machine learning approach, namely naive based, and a lexicon based approach, namely semantic based. The dataset which is going to be used has been created by ISEAR. This dataset is an annotated one. This means that each sentence has an emotion associated with it. This dataset contains over 7,000 such statements. The data which we have cannot directly be used for emotion recognition. It needs to go through certain pre-processing steps in order to become recognition ready. The first pre-processing step is tokenization. Tokenization is the process of breaking down the stream of textual data into words or phrases of meaningful elements which are called tokens. White space characters are usually used to separate tokens. These tokens are given as input to next mining steps. The next step is POS tagging. The most useful POS to find emotion from text are noun, adverb, and adjectives. POS tagger or parts of speech tagger are used to find them and extract the key terms that are wanted. The task of allocating to each word in a sentence parts of speech like verb, adverb, noun, adjective, preposition, or other lexical class marker is known as parts of speech tagging. The third step is stemming. Stemming is the process of converting words to their seed form. WordNet lexicon is a comprehensive collection of stem words only. It helps in stemming the non-stem words by swapping them out. This enables the algorithm to match the words from textual data to the lexicon. We will be using NLTK's port stemmer function to perform the stemming. In addition to these three, another important pre-processing step is negation check. The appearance of negation words may change the opinion orientation. An example, not good is equivalent to bad. Words such as not, never, nothing need to be taken into account and adjusted for. These are some of the snapshots of our pre-processing steps. Out of all the data that we have, we will be using 9/10 of the data for training and the rest 1/10 for testing. Let's start with the first method, which is naive Bayes. Naive Bayes is a popular algorithm in text classification. Naive Bayes classifier is a simple probabilistic classifier which is based on Bayes' theorem, which has strong and naive independence assumptions. This here is the formula underlying the naive Bayes classification. This is called supervised machine learning because we are showing the machine data and telling it this emotion stands against this sentence. Then after that training is done, we show the machine some new data and ask the computer, based on what we taught the computer before, what the computer thinks the category of the new data is. We start by counting occurrence of all words in our whole data set and making a dictionary of some of the most frequent words. We calculate the probability of occurrence of each label. Feature selection mechanism used in the training phase is basically where we select which data to train the classifier on. This is nothing but words with probability of occurrence in our trained data files. Now we have words and its corresponding probability relative to each of the defined emotional label. After we have trained and tested the data, we use the naive Bayes classifier library provided by the Python NLTK. These are some of the informative features of our naive Bayes classifier. The next approach is lexicon-based. Typically, lexicon-based approaches for sentiment classification are based on the insight that the polarity of a piece of text can be obtained on the ground of the polarity of the words which compose it. The sentiment conveyed by a sentence is the sum of polarity conveyed by each of the words which compose it. Polarity of each word depends on the sentimental score of each term in the microphrase, which is obtained from the lexical resource. In our case, the lexical resource which is being used is WordNet effect. If WordNet effect is being used, the algorithm tries to map each term to one of the nodes of the affective hierarchy. These are the steps of a lexicon-based approach. After the emotion lexicon has been formed, we calculate the sentiment orientation score against each word, which is then used to classify them. The next approach is semantic-based. Here we make use of the Gensim package provided by Python. In the first step, we form a dictionary which is mapping between normalized words and IDs. The token to ID is used to assign a unique integer ID to all words appearing in the corpus. This sweeps across the text, collecting word counts and relevant statistics. In our case, we have 6392 unique tokens. To convert the documents to vectors, we'll use a document representation called bag of words. To actually convert tokenized documents into vectors, the function used is doc2bow. It simply counts the number of occurrences of each distinct word, converts the word to its integer word ID, and returns the result as a sparse vector. In the fourth step, We use the corpus of the previous step to initialize or train the transformation model. In case of TF-IDF, the training consists simply of going through supplied corpus once and computing document frequencies of all its features. Transformations can also be serialized on top of one another, like a chain. Here we have transformed our TF-IDF corpus via a latent semantic indexing, also known as LSI, into a latent 2D space. After this, we try and test our data to calculate the accuracy. These three images show accuracy of all the three algorithms explained before. Now let's go ahead with the project demo. The project has been developed entirely using Python. As mentioned before, we make use of packages like NLTK, GenSim, sklearn, and TextBlock. So this is the data set which we are going to use. These are the emotion labels which will be used to calculate the frequency of the words, and these are the negation words which will be used for negation check. This step performs the removal of all the errors and tokenization, and this step performs POS tagging. This step performs the stemming. After the pre-processing tasks are done, we put the data in a data frame which will be then turned into a test and train data frame. This here are the stem words generated, and these are the emotion labels which have been detected. In the lexicon based approach, we first make a list of all words semantically related to an emotion label, and we then create an emotion word net. Then we use the classify lexicon method to calculate the accuracy of our algorithm. As can be seen, the total accuracy of lexicon based approach is over 23%. However, when we consider only those sentences that contain the lexicon, the accuracy rises to over 54%. In the naive Bayes classifier, we first consider all the words in our dataset and we calculate the frequency distance between it. This is the feature extraction step explained before. We then declare the classifier which will be used to train the data. After we have the train and test data, we execute the classifier. The total accuracy of naive Bayes is over 64%. These are some of the informative features of our classifier. This here represents a small example of how our classifier works. This statement has been annotated to this emotion. This is the semantic based approach. After we are done with the pre-processing steps, we first create a dictionary. Then we assign a tokens to each a token IDs to each of the tokens, which has been shown here. As mentioned before, our dictionary has 6392 unique tokens. We then use the doc to bow method to convert the tokens into a sparse vector. This is the step where we initialize a TF-IDF model. Here we apply a LSI model over our TF-IDF. We then create our test and train data. After applying the semantic function, the accuracy of semantic based approach turns out to be over 12%. Thus, as part of this study, we have taken into consideration the most commonly used and efficient algorithms. Although the accuracy of these algorithms is now low, it can be severely increased by training the data over a large annotated dataset. Thank you for watching.